So we are going to learn how to determine if a molecule is in the R orientation or S orientation. So the steps for determining if something is in RS orientation is first to assign priority. Priority is assigned based on atomic number. The higher the atomic number, the higher the priority. The more priority it has, so it'll be the lower number. If it has equal, so if you have two carbons on the other side, then you move on to the next atom. So what that means is if you have a carbon and you're assigning priorities and you have a carbon on the other side, they have the same atomic number. You can't distinguish. What if this carbon has a hydrogen next to it and this one has an oxygen? This carbon will take the priority because oxygen has a higher atomic number than hydrogen. We will then assemble our model kit to resemble what our molecule looks like, using different colors for priorities. So priority 1 can be red, 2 can be green, 3 black, and 4 white. It doesn't matter, they're arbitrary, but it is important that you know which color corresponds to which priority when you do it. And then you rotate your molecule so priority 4 is facing the back. And then using the remaining 3, so you'll have a 1, a 2, and a 3, and just pretend those are different colors, not numbers, because the model kit will not show numbers, it'll show colors. We go 1, 2, 3, and as we can tell, this is going clockwise, which would be in the R formation. However, if the priorities when they're facing you, when 4 is placed to the back, looks like this, 1, 2, 3, going around, the priorities form a counterclockwise position, meaning that they will be in priority S. Okay, so we're going to determine if this molecule is R or S. The first thing to do is assign our priorities, like we said. So we see a nitrogen and 2 carbons. And don't forget, also hidden, there is a hydrogen. And that'll be in the opposite configuration of the NH2, so it'll technically be like this. It'll be a dashed line. Okay, so now we use our periodic table and we look at our atomic numbers. Carbon has an atomic number of 6. Nitrogen has an atomic number of 7, hydrogen 1. So 7 is the higher number, so this will have the highest priority. It'll be number 1. Next is atomic number 6 are carbons. Now, as we can see, we have a carbon on either side. So which one gets assigned priority 2 and which one gets assigned priority 3? Well, if we go this side to the right, the carbon atom we're looking at, that is our chiral center, is attached to the carbon atom, and then that carbon atom is attached to 3 hydrogens. Whereas on the left side, our chiral carbon is connected to a carbon, another carbon. So hydrogen has a lower atomic number than carbon, so this one will be assigned priority 2, and then this one will be assigned priority 3. And now we are going to look at our final atom on our chiral center, which is a hydrogen. That hydrogen will be assigned 4. If there is a hydrogen on a molecule, it will be assigned number 4 because nothing has a lower atomic number than hydrogen. It is atomic number 1. Again, this is on the wedge, so now we're going to look at how to assemble our model kits to determine if it's R or S. Okay, so we assigned our priorities to our molecule, and we have our model kit here. So now, we're going to assign priorities. So I always assign priority 1 as red, priority 2 as green, 3 as black, and 4 as white. This will represent our center carbon. So we need to assemble this like we would the molecule. So the first priority is facing towards us, as we can tell by the black wedge. So here, we'll assign priority 1, which is red, as coming towards us. And next, we have priority 2 going left and 3 going right. So 2 will go on the left side, and 3 will go on the right side. And that hydrogen that's facing away from us, which is on the top, will go on the top, on the remaining right here. So we have formed our molecule. And then we're going to rotate it. So our fourth priority is facing back. And then we'll go red, green, black, which as we can tell takes us in a counter clockwise position, which we will assign an S priority. So this molecule is an S molecule. Okay, and we're going to do another example. So that one was S. So we're going to look here. So our chiral center, our chiral carbon is, you don't see that. Okay. Okay, so we see our chiral carbon is here. So assigning our priorities, bromine, has the highest atomic number, so that'll be assigned priority 1. Next, we'll have our carbons will be assigned 2 and 3, but which one? So on this side, we go carbon, carbon, hydrogen, hydrogen, hydrogen. Whereas here we go carbon, 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 carbon. So this will be assigned priority 2. This will be assigned priority 3. And there are no double bonds here, so we know this carbon will form 4 bonds, so there is a hydrogen secretly drawn here, and that hydrogen will have the 4th priority. As we can tell here. And then we'll assemble our model kits. Okay, so we just send our priorities again. Red is priority 1, green priority 2, black 3, and white priority 4. So in the up direction, facing kind of towards us, we have bromine, which is our first priority, so we put red there. Priority 2 goes to the left, so that'll be our green. Priority 3, our black, will go to the right, and then this last one facing back will be the hydrogen priority 4. So go ahead and assemble that. Now, like for us, it's already been flipped where hydrogen's, the fourth priority is facing back. And we can see it goes red, green, black again. So this molecule will also be S. Okay, so as I said, this will be an S molecule. Like chiral center has an S orientation. I hope you learned something about determining if chiral centers or S or R. This is a useful tool in nomenclature. As you've seen in your organic chemistry textbooks, when you have chiral center, usually in the IUPAC name, if it is R or S, it will be in the name, because stereochemistry does typically make it in the names, in either the form of R or S, or in the case of double bonds, E or Z. So again, thank you for watching, and I hope you learned something.